today. Don't tell my advisor. I should have been doing schoolwork, but here we are. But guys, before I start talking about distant starlight stuff, because that's what we're going to talk about tonight. I want to show y'all the hail that ended up in my backyard last night. So I've got, oh shoot, I forgot. I gotta pop this over here, and then I'm gonna pop this over here, and then I'm gonna go over here, and then this button. Okay, this button, share. This is the hail that we picked up off my back porch. We got solid 2 to 3 inch hail. So that's like golf ball, ping pong ball sized. I had some of my husband and I were having another like couple over for dinner, and one of them is also a weather person. So we were sort of nerding out about the hail, and then also worried, so today I've been on the phone with the insurance company today because we're going to get a new roof. So that's the hail we got. And this is very cool. I think it's very cool. This is the radar signal that you only get this radar signal with lots and lots of like big hail. Hello, Tribica. I think I said that right. And thank you very much. Tribica bought me a coffee. So my channel isn't quite monetized yet by YouTube standards, but I did finally decide to set up a like buy me a coffee link. It is down in it's in the description of this video. So your generous coffee donation is much appreciated. Definitely keeping me caffeinated is a great way to get more videos. Anyway, this is the hail signature. And what's really cool is this, if you see those like that just long line in the radar, right? That just like shoots out from the like storm cell down to the southeast. That is what's it called? A 3-body echo. And what happens is the radar signal hits the hail, and the hail is really big, right? So then the hail, the radar signal reflects off the hail and hits the ground, and then bounces off the ground back to the radar. And so the radar then thinks, right, because the radar only knows how long did it take for the signal to get back to me. So the radar picks up both the signal that just bounced off the hail, and then the signal that took longer to get back, that bounces off the hail, off the ground, and then goes back to the radar. And so the radar thinks that you have more hail further away. So you get this artifact in the radar that, while it's not indicative of actual material in that line, it's a unique radar signal you only get with like really big hail. So this was from the storm that hit my house last night. 3-body scatter spike, exactly. Yeah, this is a super classic 3-body scatter. Like this should be in a textbook. This picture is so good. And I snagged this picture off of Weather Twitter. I forget exactly who from. But I wanted to share that with you guys before I got into young earth creationism stuff, because I'm a weather nerd and it's storm season in Oklahoma and my roof got destroyed yesterday. I'm actually really lucky. Some of my friends, like the windows on their houses got blown out and like there's holes in their siding. Our roof just got damaged. And I know I'm saying that really casually, but if you live in the middle of Tornado Alley, right, like you're gonna have to buy a new roof every 5 to 10 years. It's just a thing that's gonna happen. Thank you, Secular Rarity. And I'm super glad you're here. Okay, so enough of hail radar signatures. And let's start talking about distant starlight. So I have a video. I haven't watched it yet. but I found it. Here we go. It's from our good friends over at Genesis Apologetics. And I think I clicked the wrong button. So I'm going to stop sharing because I have to remember to share the audio when I share the Chrome tab. So share audio, that button. There we go. Perfect. Okay, and I'm just going to rearrange a few things on my screen so I can keep an eye on chat. How much general relativity do we need to know for this? Not much. And you only need to know a little bit of special relativity, and I'm gonna explain it. And yes, Vesta, absolutely. A model that there's a lot of special pleading involved. Absolutely. And hi, B, good to see you guys in chat. Oh my goodness. Okay, so let me hit play on the video. And we'll see what we've got. In store for us tonight.
God wrote in the 10 Commandments that he
So
created
loud.
the heavens and the earth, the sea, and all that is in them in just 6 ordinary days. The genealogies in Genesis connect the lives of the early patriarchs straight back to Adam, just thousands of years ago. So how can we see the light from distant stars when it supposedly took billions of years for their light to travel to Earth?
Right. So that's just phrasing the problem, right? And the problem is simply, oh, okay. I'm glad it's perfect volume B. It was loud in my headphones. So the basic problem is if we see stars that are like 100,000 light years away, that means it took the light 100,000 years to get to us. So how is it that we can see objects in space that are further away than 6,000 light years if the Earth is only 6,000 years old, if the universe is only 6,000 years old, right? How could we possibly see something further away? And so that's the problem. It's not a problem if you just accept the universe as it is, but it is if you're trying to prove or demonstrate that the universe was created in 6 24-hour periods. Anywho, all right.
Does this disprove the clear timeline in the Bible and show the rest of it as just myth?
Yes,
Actually, it doesn't.
Oh,
stay with us to find out why.
I'd love to.
You see, to measure the speed of light at any time in history, you need 6 things.
I'm gonna put a little point in that, because you notice there that he said in order to measure the speed of light at any point in history. I feel like he's trying to prep you to think that the speed of light is not a constant. The speed of light is constant. It's the coolest constant in the universe because it's a non-reference frame dependent constant, which is very strange and very cool. And no matter how many times we measure it, it's always the same. It's always 3 times 10 to the 8th meters per second in a vacuum. And if you could change the speed of light, like you would completely revolutionize physics, and like everything we know about physics would be wrong, right? So like that's not a light accusation or a light sort of question to just toss up there so soft bally like he did. Because I think he's trying to prime the audience to think that we don't know what the speed of light was in the past. No, we do. We very much do. Okay.
Light, space, distance, matter, time, and gravity. From a biblical perspective, God, who is outside of time and space, created all of these things during Creation Week. None of them even existed before that. Think about it. They all had to come into existence together at the same time.
Why? Why, though?
Without space, how can you have distance? Without distance, how can you measure speed or motion? What would matter be like without gravitational forces? And gravity even affects time. Light travels through this space-time fabric, and all of these things were spoken into existence by God.
Oh, goodness. I don't know if this is going to be a one-way speed of light thing. We'll have to see. Yeah. All right.
During the first few days of creation. These are all pieces of a puzzle that came together at the beginning. Light is visible electromagnetic radiation that travels 180.
Oh my goodness. That's not even a true statement. He said light is visible electromagnetic radiation. That's not true. Visible light is visible electromagnetic radiation, but we would refer to the entire electromagnetic spectrum, any electromagnetic wave. It's fine to just call that light, right? You can use electromagnetic wave and light interchangeably. And in fact, if you mean visible light, then you need to specify that you mean visible light. I don't think our narrator or the writers of this video over at Genesis Apologetics have taken many physics classes.
86,000 miles per second when it's in a complete vacuum. The speed of light when traveling through space is impacted by gravity, and time and gravity are inseparably related.
Okay, so yeah, time and gravity are inseparably related, I guess. So what they're leaning at there is that the way that I experience time is very much related to my acceleration, right? How fast I am moving through space, which is pretty much determined by gravitational pull of large objects, right? So it's a little, I don't know. I feel like when you say that, like, oh yes, time is inextricably tied to gravity, that's almost like, I don't know, that's almost confusing the way that's stated, right? Like it's almost, you could say that more clearly, right?
Gravity impacts the speed of light because it affects the energy of.
That's not true. Oh my goodness, that's not true. I'm gonna back it up and I'm gonna let him finish that whole sentence. And then I'm gonna explain what's wrong with it. Okay.
Inseparably related. Gravity impacts the speed of light because it affects the energy of the fabric of space, which.
Okay. Gravity affects light because it affects the energy of the fabric of space. I don't know what that means. I literally don't know what that means. So one thing that's important to note is, like, if we have light traveling through a vacuum, gravity, you can put as much gravity there as you want. It's not going to affect the speed of light, right? The only, yeah, absolutely. It impacts the frequency. So the energy, it impacts the frequency, right? The energy of a photon or the energy of an electromagnetic wave is Planck's constant times, is it Planck's constant times wavelength? No, it's Planck's constant times frequency. Sorry, I have to write it out. That's how I know that. So if you change gravity could certainly like affect the path that light is traveling. We know that with black holes. It can affect the energy of a photon, right? The energy of the electromagnetic wave, but changing the energy of the electromagnetic wave doesn't actually change its speed. So if you take energy away from, say, visible light, now you just have infrared light, right? It just changes. If you change the energy, you change the frequency. If you change the frequency, you change the wavelength, right? So that the speed of light is equal to frequency times wavelength. So, but you can affect the energy all day long and never affect the speed. And that's very important to understand. And I think where a lot of people get confused with that is that when we think about energy, you and I often think about kinetic energy, right? Because we think about, well, if I'm running really fast, I have more energy than if I'm walking. So that's true, but that's talking about the kinetic energy. The energy of a photon or the energy of an electromagnetic wave is not kinetic energy. Photons don't have kinetic energy. They don't have kinetic energy because they don't have mass, right? So you can't have kinetic energy is 1/2 times mass times velocity squared. So a photon cannot have kinetic energy. It has photon energy, and you can turn photon energy into other forms of energy. But a photon in and of itself does not have kinetic energy. It just has energy, and it's kinetic energy that's affected by speed, right? Okay. Cool. So let's and the energy of the makeup of the fabric of the universe. I'm not actually sure what he's trying to say there. One way to think about gravity is if you imagine space-time to be a rubber sheet, and then you can think of gravity as it relates to mass, so that if we put something that it has mass, like the Earth, on this rubber sheet, it would bend the rubber sheet. And so one way to conceptualize gravity is to think of gravity as the bending of that rubber sheet, of the space, of the fabric of space-time, if we're going to be a little poetic. But that's more of a way to think about things. And if you think about things in that way, then it's easier to understand something like a gravity wave, which would be a ripple in that sheet that continues on. But it's much more of a way to think about the universe and sort of wrap your head around what's going on with gravity, than it is an actual description, right? Anywho, okay. Let's keep playing the video. Let's see what he has to say.
Which in turn affects the speed of light and time.
Speed of light and time? I'm sorry, what? Oh, okay, yes. So it doesn't affect the speed of light, we established that, but it could affect by what is the speed of time. I think what they mean there is the rate at which a person or an object or something we can measure experiences time or goes through time. I've got to stop pausing him every second, but seriously, he hasn't gone 5 seconds without saying something ridiculous.
Atomic clocks at different altitudes track time at different rates due to gravity. Even our GPS systems need to be calibrated for the effects that gravity has on time. Lastly, even motion itself affects time.
Are those Klingon ships? Those look like Klingon ships.
When accelerating close to the speed of light, the weird distortions of Einstein's relativity kicks in. Time slows down, lengths go up, masses balloon, and everything we thought was fixed changes. So there we have it. Light, space, distance, matter, time, gravity, and
those are all things that exist in our universe. And he did just basically explain special relativity. If it comes up again, I'll dig into it a little bit more.
Motion. Just put them all together at a given time in history, put them into a formula, and presto. We think we can measure just how and when it all got started. Apparently looking back through millions of unseen years when the entire universe unfolded with this perfectly timed, perfectly bounded Earth spinning on its axis 1,000 miles per hour, while orbiting the sun at 67,000 miles per hour.
I just want to point out that the rate at which Earth rotates is a thing that's changing all the time. It's being slowed down by the moon. One of my favorite fun facts is that the earthquake that caused the Fukushima tsunami and nuclear disaster, that earthquake, so what happened was you had a subducting ocean plate going under a continental plate. And so imagine it as like it slipped and it jammed down deeper into the mantle. So that measurably decreased the Earth's radius and thus increased our rate of rotation. So just this idea that we're rotating at the exact right, precise thing, but it changes, right? It changes, and it doesn't change so much that we can't really adapt. It changes slowly, right? Or in the case of the earthquake, it changed quickly, but not by a whole lot, but by enough that I think it increased the length of our day by half a second or something like that, which is kind of nuts. I just don't like the fine-tuning argument. It doesn't really make sense to me. And sometimes I feel like, especially Earth creationists, like to just say big numbers and be amazed at big numbers, and then somehow that means God. I don't fully get it. I don't really understand why saying we're spinning at this spot. I don't understand why that's supposed to how does that support one way or another when the Earth was created, how fast we're rotating, right?
Do any of us really know the complexities of light, space, distance, matter, time, gravity, and motion?
I mean, no one understands all of it, but there's a lot of people that understand it more than you do, my guy. Right.
Can we change the relationships between these on a grand scale in our universe today? Do we know for certain that their relationships today are the same as they were thousands of years ago?
So this is an argument that comes up a lot in young Earth creationism, right? How do we know that things that we measure to be constants today were constant 100 years ago or 1,000 years ago or 1,000,000 years ago? And the best answer we have, right, is can I know absolutely 100% for sure? No, but since we haven't figured out a way to change it, right? If it's like speed of light, no matter how many times we try, we can't change the speed of light. Same thing with like nuclear decay constants. No one has ever been able to change a nuclear decay constant of any element, right? And so like it is a much better assumption, right, that these things have not changed because we have no evidence to suggest that they have, right? That's a much better assumption than, oh, well, I don't 100% know, like what this gets down to is like the stupid like philosophy 101 question, right? Which is like, prove that the universe didn't come into existence 10 seconds ago, right? And all of our memories are just illusions. You can't prove that, right? It's highly improbable, but you can't like like in the mathematical proof formal sense say that that's like uh that's the most reasonable assumption about the way the world works, right? Sorry, I got distracted by chat. Mr. Autopants. Oh my goodness, there's 19 people watching. Thank you guys for spending your Thursday with me. So man, I remember years ago in the 90s when I saw a Ken Ham video on public access, called the number and asked them about distant starlight. Ken Ham himself told you it was slower back then. I would love to have listened to that. That'd be interesting. I'd also love to see what evidence Mr. Ken Ham there has. Yeah, last Thursdayism. That's the you can't prove it, right? And it's also not the most reasonable conclusion about the evidence, right? So if we're going to go with the most reasonable kind of how can we be the least wrong, then a lot of these things we're going to just assume are constant unless we have evidence for other things. Okay.
5,000 years ago. What about when they were created? God is not bound by the laws of nature as we are. This is important to realize when it comes to the creation
very much just
when
whataboutism.
God, who is outside of space and time.
Right. This is just, we're getting to an appeal to magic, right? So if and a lot of times, here we could replace his like, but God isn't held to our rules about space and time. Replace that with your favorite wizard. Replace that with Rincewind, or Gandalf, and just say like, oh, well, Rincewind isn't held to our rules about space and time. So therefore he could make it be like this, right? That's not a good argument, right? And it's certainly not a scientific argument. Like I propose that there exists a being that doesn't have to follow any of the rules of physics. What could that being do to the rules of physics? That's not science. I mean, that might be good science fiction, but like, oh gosh, I didn't mean to quote Kent Hovind then when he likes to say, but that's not science. It's like a really annoying thing. But like, this is explicitly appealing to supernatural processes, right? Which science can only deal with the natural world. Anyway.
Created the stars, light, space, distance, matter, time, and gravity. Even the evolutionary model, the Big Bang, has a light time travel challenge called the horizon problem, as explained by astrophysicist Dr. Jason Lisle.
So I know Jason Lisle is very, very much a creationist astrophysicist. I haven't dug a lot into the horizon problem. So I would have to read up on that to understand what the actual issue is, and if there's an actual issue versus like a lot of times it's only creationists that think there is an issue. So it actually takes me a while to kind of find what the actual argument is, if that makes sense. So if he's going to talk about the head, or let's just see what he says the horizon problem is.
The Big Bang, the alternative to biblical creation, also has a similar type of problem, a light travel time problem of its own. It's called the horizon problem. And basically it has to do with the cosmic microwave background that we see streaming from the distant regions of the universe. We find that it's very uniform. And that shouldn't be, because in the Big Bang model, it should have different temperatures at different places. Why is it so uniform? Obviously, light energy had to travel from the hotter regions to the cooler regions to equilibrate those temperatures, but there hasn't been enough time. Even in 13.7 billion years, there's not enough time for light to travel from one side of the visible universe to the other. And so that's a light travel time problem for the Big Bang. It seems to me that if the alternative to biblical creation has the same type of problem.
Well, okay, I think we're going to do like a, okay, so I'll have to look into that. I'm not going to dig into it right this second because I want to get to some of the other distant starlight stuff. But like, yeah, this is just like, I understand the like there, I think I understand the temperature thing, but I don't want to do that live. So let's keep going.
As biblical creation, then you can't argue that distant starlight somehow disproves biblical creation in favor of the Big Bang. And after all, God is omniscient.
See, but no, these are different problems, right? There is like, it's a very different problem of like, how do you have heat more uniformly mixed than we think it should be? Like, how does that work? Then like, you physically don't have enough time to we should not be able to see the majority of the stars that we see at night, right? Those are very different problems. And I don't like that he's equivocating them here. That's not, no.
Could have used a mechanism that we do know about, or he could have used a mechanism that we don't know about. But it's not a problem for an infinite God to get light from distant galaxies to Earth in thousands of years.
Sure. Magic in a way that we cannot test or observe, that left no evidence, right? Like, and that's a very silly thing to appeal to if you're trying to appeal, to a scientific explanation. Okay. Oh, we're gonna go to an ad.
Process ensures your
Sorry, I think I'm gonna get a lot of roofing ads because of the hailstorm. Unmute.
Anticipating the light time travel question when he asked Job to gird up his loins like a man and asked him, where is the way to the dwelling of light?
Okay, we're gonna go straight to Job. That's all right. Let's skip through some of this. I'm not really, we don't need to, there we go.
Beginning. We can measure how they interact in today's world, but don't you think they operated much, much differently when God put them here?
No, why would I think that? Other than you're suggesting it, right? Don't you think that the universe used to work completely differently, but then left absolutely no evidence of that? No, I don't think that. That seems like a very silly conclusion to me. Goodness. Yeah, okay.
And shape them during creation week?
Oh, gosh.
Can we really be certain that they operate the same way today as they did in the distant past?
Yes, to the degree of evidence that we have, right? Like, and I think that's one of the things, like it's asking, this I think comes up a lot with basic science denialism, right? Because you see it like in, you see it with like people that deal with like, don't like that are climate change deniers, right? Like I deal with that a lot of like, well, do you know for certain, like, and they want a degree of certainty that just doesn't exist in science, right? And so this like, and it's basically boils down to Ken Ham's, but were you there? I can't do his accent. I'm sorry, I can only do Southern accents. That's all I got. Yeah, so like, absolutely. Like if I can't assume that like physics works the same today as it will tomorrow, then we shouldn't like we should not trust cars, right? We shouldn't, then because if physics can just change willy-nilly, then you can't, like, you can't make anything, like you can't do science, right? Because science requires things to be like repeatable, predictable, testable, right? All of those things. And we have different tools for doing that, but like it's a really bad assumption to think that like fundamental laws used to be different, right? That's not a casual thing to throw out there like this video is doing. It's throwing out the idea that the universe behaved fundamentally differently in the past, and that's not a reasonable thing to suggest. That's like a cataclysmic, catastrophic thing to suggest. Okay. Let me go back to sharing my screen. Oh no, not that way. This way? That way. Okay.
The first verse of the Bible reflects time in the beginning. Energy,
Yep.
God created, space, the heavens, and matter, the earth, all coming together for the very first time. We should be reminded by the psalmist, by the word of the Lord the heavens were made, and all the host of them by the breath of his mouth. For he spoke, and it was done. He commanded, and it stood fast. How easily we forget that the natural laws at work today are not the same rules God used to create everything.
Prove it, right? Demonstrate it. And you can't let your answer be, they had to be, or else the biblical account isn't accurate, right? That is not a scientific claim, right? That's like a faith claim, right? And so if that's what you like, again, I'm not going to tell somebody what they can and can't believe, right? If you choose to believe, like, I understand that none of the evidence points to this conclusion, but my faith requires that I believe it anyway, right? To me, yeah. Then like, I'm so distracted by chat. I'm sorry. I apparently can't do two things at once. Secular rarity. No, I don't think he's given any evidence other than the Bible says, right? And just like, and the Bible says it's just not a scientific claim. And that's what really bothers me about a lot of young earth creationism is that they'll say, well, science points to X, right? But then not give a scientific answer, right? It really bothers me. Okay.
The Bible is clear. By faith, we understand that the worlds were framed by the word of God, so that the things which are seen were not made of things which are visible. So here we are, spinning 1,000 miles per hour on this globe, traveling around the sun at 67,000 miles per hour. And we think we can know with certainty the nature of light over millions of unseen years? God said something.
Yes. Goodness, yes. There's lots of things we do not know about the universe, but the speed of light we understand, right? Goodness.
To the prophet Isaiah that sure seems to apply today. For thus says the Lord.
Goodness. Okay, let's get a
no other
stop
that explains the light travel phenomena. First, a short background about Dr. Humphreys. In 1984, Dr. Humphreys developed a theory based on the biblical account, which says that God created the planets out of water just thousands, not millions of years ago. Dr. Humphreys' theory was able to make several testable predictions about the magnetic fields of Mercury, Mars, Uranus, Neptune, and Pluto. Then,
but maybe weirdly not Jupiter and Earth, whose magnetic fields would be the biggest and the most interesting. Yeah.
Years after Dr. Humphreys made his predictions, NASA space probes reached these planets. Humphreys' predictions were right on, and the expectations of NASA, based on the evolutionary dynamo theory, were drastically off. Even with a magnetic field being 100,000 times smaller.
The Earth was just above a timeless level, and I'll explain what a timeless level is in a moment. But you see a cross-section of the trampoline here in the vertical direction.
Okay, this is our like rubber sheet idea. I don't know what this timeless thing is. I hope he does actually explain it.
Is gravitational energy, and the horizontal direction is distance away from the Earth. And you see a point at the distance away from Earth, which is billions of light years, drop down on the dotted line, and you see a little slice there that says that's a section of the waters above that are making the dent in the trampoline. So then you notice to the left of the waters above, it's mostly flat, except for a little tiny dent made by that green ball at the left, which is the Earth.
What in the world are we
That's
looking
right
at?
above a certain critical depth of gravitational energy where interesting things happen to time in Einstein's equations. So what happens to time is that below that critical level, there is no time.
Okay. Goodness, what did I stumble? What am I subjecting us to, team? Okay, so what does that mean by no time below the critical level? Because that's like not a thing that makes sense, right? And the only thing I can think of, because he's specifically referencing like Einstein's equations, what I can think of here is going to be referencing like what happens to the way objects experience time in special relativity. And so what that is basically if I am stationary and you are moving really fast, close to the speed of light, then time is going slower for you than it is for me, right? So we both start here on planet Earth. You get into a special spaceship and fly really close to the speed of light for, say, a year. And then you come back and, oh my goodness, I am long dead because it's been 100 years back here on Earth. So there is a point exactly at the speed of light, right, where you kind of don't experience time. And that gets real philosophical. But imagine it like this, right? Then like no time is passing for you. So if the closer you get to the speed of light, the slower time is moving for you, and it's kind of asymptotically approaches, like the amount of time that passes for you asymptotically approaches zero as your speed approaches the speed of light. Yeah, relativity is pretty crazy. It's very cool though. So like for an individual photon, photons might not notice, but they might not experience time. Luckily, they're not sentient, so I don't know what that means, right? So the only thing I can imagine that this figure is supposed to be referencing with this no time below the critical level is this is an amount of gravitational energy that's associated with an acceleration and therefore a speed that is the speed of light, right? Now the Earth can certainly, nothing other than light can travel at the speed of light. It's a very unique property. I guess technically another particle without mass maybe could, but like the Earth definitely has mass. Things with mass, things with mass cannot travel at the speed of light. So basically you can break the universe down into three categories: things that travel slower than the speed of light, things that travel faster than the speed of light, and we're not entirely sure things that travel faster than the speed of light actually exist. It's sort of one of those things, like there's no reason they shouldn't. We've just never found them, and we don't know if we ever will. They could, but meh, right? So kind of like unicorns, right? There's no reason why a unicorn can't exist. We've just never found one. So yes, so Earth definitely couldn't be on that line. Okay. Also, here's another problem with this diagram. There's a lot wrong with this diagram. So the line being flat doesn't make sense. And this waters above dot not affecting space-time the same way on its left as it does on its right. That doesn't make any sense because That would be like, that's a directional gravitational pull. So that's not really like possible. Gravity affects like everything in all directions, right? There's nowhere on Earth where I can stand like how strong the Earth's gravitational pull is on me is just a function of how far away I am from the center of the Earth, not like if I'm at the North Pole or the South Pole, right? There's no direction. I can only move further away, right? Radially outwards, like have my total distance increase. But if I moved around in a circle, then I am affected by the gravity in the same way everywhere. So that curve to me makes zero sense, because there's no way, unless we're going to just appeal to magic, right? There's no way that the waters above would cause this bend in space-time corresponding to gravitational energy unidirectionally, right? It has to be in all directions. I hope that made sense. Yeah, okay, so let's see what else he has to say.
Time doesn't tick. You don't notice, you can't think, and
so that time doesn't tick, that again, that's, you would be at the speed of light, which nothing with mass can exist at the speed of light because your mass becomes infinite as you approach the speed of light.
There is no light, so it's dark. Here I'm going to begin to show you why this effect is so important in cosmology. During the fourth day, God created the stars.
Okay.
Now, I'm going to suppose it's not necessary that God created the stars in a wave moving out from the earth on the fourth day of creation. So now let's go back to a cross-section of our trampoline. Instead of looking down on it, let's look at the cross-section again.
Okay.
And the point of this is that new star masses, the stars that God made, the new ones he made, dented the trampoline yet further. So there's a wave of new stars, and you notice the dent is now tilted down, and it's really deep.
So this idea here, gravitational energy, I'm assuming he means gravitational potential energy, which would be like, so it's the same idea as like, you have more potential energy if you stand on top of a building than if you stand on the ground, right? Because you could convert that potential energy into kinetic energy if you fell off the building. Yeah, so I think this is just supposed to reference gravitational potential energy. Yeah. Right, exactly. This would mean that the Earth is timeless, and specifically that would have to mean that Earth is traveling at the speed of light, which it certainly can't. So this doesn't make any sense. Now, I do see what his little model here is doing. We add mass, and if we add mass, then we bend our sheet more. But like what he's saying is nonsense. Like this doesn't make any sense at all. And native atheists, like maybe, but poorly. Also, dude, are you okay after the hailstorm yesterday? Anywho. Yeah. Okay. Hail. Nope. Okay. Sorry. I'm like geeking out more over radar signatures right now than I want to do really, I cannot express how bad this physics is. Like it's really, really, really bad. And it just has some like word salad in there to make it feel reasonable. And is it Strabica? Am I saying, I hope I'm saying that right. I'm really sorry. Yeah, if it's around the Earth like that, then the gravity from it will cancel out on the inside. Yeah, absolutely. Right. Like, goodness, I don't, like, turns out, team, water has mass. Like, water is going to bend the plate. Goodness. Bend our little trampoline here. All right. Okay.
Deep near the Earth, and it's shallow, a little shallower at the waters above. Okay? now we have a new scriptural effect to talk about, stretching out the heavens.
I think he might talk about, so I don't, is he done? Is he done with his explanation? Because he didn't say anything. Okay, let's move forward.
God stretched the fabric of space. How do I know that? 17 verses that say things like this. God stretches out the heavens like a curtain.
That's fine. I think what he's going to try to say is something to the effect of like, oh, see, that's like the bending of space-time, right? That's clearly what that's referencing. That is not what the author of Isaiah was talking about. Do you think the author of Isaiah thought to think of the universe and as space-time? Einstein discovered this like 100 years ago, team, right? Like the author of Isaiah did not.
And spreads them out like a tent to dwell in. That's Isaiah 40:22.
That's a lovely bit of poetry, but like you shouldn't go to Isaiah to understand how the universe works any more than you should go to like Emily Dickinson, right? God stretched out the holy trampoline. Yes, the holy hand grenade, and the counting shall be 3. The number that thou shalt count shall be 3, and the number of the counting shall be 3. Thou shalt not count to 2, nor 4, and 5 is right up. Something like that. Somebody please make a cleric character who has a holy trampoline. Like, I want that to be your spiritual weapon. I'm here for it.
Imagine some big hands on our trampoline applying tension to the edges. So God stretched the fabric of space, and that would make the nearly flat region rise upward. So you can kind of imagine if you stretch the trampoline, you're going to apply more force to that ring that's sitting, making the dent.
3, my lord, 3.
So here we are starting the action just after God has made the dent deeper with the stars. And now we're going to apply stretching and pull all of that up. So I want you to keep your eye on that vertical.
Good God. Okay, this also implies, team, that like space has an end or an edge. It does not. It doesn't. It just doesn't. Universe, weird.
Red arrow that's labeled event horizon.
Event horizon as in like of a black hole? As in like the event horizon is just like the end of the point of the black hole that you can see because everything else got sucked into it. Goodness. I'm going to let you answer that one for yourself there, Eric. No, I'm sorry. I'm being sarcastic. I don't need to be sarcastic towards you. Of course he doesn't, right? Of course he doesn't. Because he does, because this is nonsense.
Things to the left of the event horizon are going to have no clocks ticking. They're going to be in
Prove
time
it.
zones. Things to the right of the event horizon have normal time. So you're going to watch as we stretch the fabric. We're going to raise the dent above that dotted line, and we're raising things above the timeless level. And you'll see the event horizon move to the left. And so as it moves to the left, more and more of the galaxies pop out of the timeless zone and start emitting light again.
What?
Move inward all the way to the center. And the last thing that the event horizon hits is at distance 0, which is at the Earth. So
I'm still, hold on. I am still baffled by what the waters above thing is doing, right? Like, what kind of magic point is this? But seriously, like, what is he proposing in the physics that would allow an object to like affect gravity differently in that way, right? What is this? Yeah, this graph seems unintelligible. Like, this is nonsense. One, like, we're supposed to be like this being linear makes no sense. I hope you guys can see my mouse, right? Because force of gravity falls off like 1/distance squared. So you always get like a parabolic shape when we're thinking about this bending, right? So this linear difference in gravitational energy, which I'm assuming we can then like, you can relate gravitational energy. Let me double check. Gravitational energy. I've weirdly been thinking a lot about gravity reasonably. Yeah, that's talking about like potential energy. I'm gonna see if there's like a good equation that's not just like MGH. Tesla, I'm sorry if I activated your cat, but yes. Oh, okay, perfect. Yeah, so this is probably what he's referencing. Okay, so energy falls off like gravitational constant times the mass of the first object, the mass of the second object, divided by the distance between them. Force falls off like 1/distance squared. Okay, gotcha. Why have I been thinking a lot about gravity recently? Because I've become weirdly obsessed with how Dungeons and Dragons graviturgy spells work. So I've been trying to figure out the physics of magic spells that I know are magic, and I just like to point out that I can make them make more sense than this current graph, right? Anyway, okay, so linear, the gravitational potential energy falls off like 1/r, 1/distance, right? Which does not that pretty line make, right? That would be like if it changed by r, right? Not 1/r. So you need, the energy would fall off like that. You're right, falling damage doesn't work right in D&D. But I do find it interesting. Anyway, right, so that shape doesn't make sense. So then the shape to the right of the waters above, that one makes sense, right? That's what it should kind of look like. But there's not going to be a hard corner, right? Like, right, like, in general, right, nature doesn't make sharp corners. Things don't change instantaneously, right? You tend to get smooth transitions. Do I know about the peasant railgun? I do not. I want to know about it. Wait, is this a D&D thing? Because that just got interesting to me. I mean, it seems like something an evil person would make, but okay. No, not more fun things. Back to bad physics. Okay. Gotcha. Okay. Yeah, this graph does not make sense. It really doesn't. Okay.
Horizon hits is at distance 0, which is at the Earth. So the Earth is the last thing to actually come above the event horizon. Remember, God made the new stars in a wave, and we're going to see that a timeless zone followed the new wave of stars. And then as stretching started pulling the dent out of the timeless zone, you're going to see the timeless zone here shrinking. So the Earth was the first into the timeless zone and the last out of the timeless zone.
We're calling these the new billion-dollar solar.
I'm sorry about ads. Okay, skip ad. Here we go.
Earth time stopped during the 4th day.
Oh, guys, is he like, oh no, we don't have to worry about how it was only 24 hours because we just got to magically make time stop happening for Earth. So what God meant, what the Bible means, it wasn't like It was 24 hours as it passed on Earth, but we're just gonna like plug Earth out of time for however long we want for funsies. Goodness, that sounds like a lot of talking around. It took a long time, right? That's what that sounds like to me. Is that what that sounds like to y'all? Okay.
And the fourth day was only 24 hours of time here. If you'd been there on the Earth at that point, you would have experienced no time during that timeless moment. It would not.
How would you experience no time and also have like infinite mass? But like he's forgetting space, or excuse me, length and mass dilation, right? Because to get that time dilation, you also have your mass becoming infinite, but the amount of space you're taking up going to zero, right? So like explain how anything survived that, right? Oh, do we get to appeal to magic again? Goodness.
Not even be an eye blink. You would be able to suddenly see all the stars all at once. So the age of the universe, when Adam saw it, was just 6 days EST, Earth Standard Time. So when someone asks you how old the universe is, you should ask, whose clocks are you talking about?
Don't ask that. Don't be an ass, right? That's an asinine question to bring up. Don't do that. Be better than that.
The ones that God gave are here on Earth.
Right, like rocks that we can date to be 4.5 billion years old. So
he wanted Adam and Eve to be able to see our own Milky Way. Some parts of it are 50,000 light years away from us.
Now we're going to decide what God wanted? Like, that sounds very arrogant. That sounds a little sacrilege, maybe. Like, you, good sir, know what that, like, you know what God really wanted? He really wanted us to be able to see the Milky Way. So he broke physics to make that happen? Goodness.
And Andromeda, which is 2 million light years away from us, you can see it as a patch in the northern sky. He wanted Adam and Eve to see the full glory of his universe.
Guys, the universe is really cool, right? But like, there's no reason why we should be able to see it.
So I think you can see that there are answers to these questions from a biblical point of view.
That's some mental gymnastics you went through there, buddy.
So I want you to be able to trust the Bible to be true.
Okay. Well, all right. Oh, okay. I think the rest of this is ads. So that's ridiculous. Actually, team, where I thought they were going to go with this, they didn't go where I thought they were going to go. I thought they were going to go to like basically relating, well, how much time has passed for the light? And that gets to be like a weird philosophical question. Right. That's actually my question, right? Because like, if at the end of the day, your argument is going to boil down to, well, God did it by magic or miraculous means, and therefore, and did so in a way that left no evidence or suggested a different conclusion. Like, if you're going to have to get to that point eventually, like, why jump through all these hoops beforehand, right? Like, why? Well, that seems very silly. So, and why do dishonest science, right? Because that's what that is, and like lie to people and intentionally misrepresent things to people. He has to know, if he knows anything about physics, like if I can just watch this and explain why that makes no sense, without doing any research, just basing it off like information I like carry around in my head, like then if you know anything about physics, you know it's a bad argument, right? And so like you have to know that guy has to know that's a bad argument, like, and he's intentionally misleading people, and that I'm not okay with. That's why I make these videos, because it makes me angry. yeah, like if at the end of the day, you're just going to get to, well, God did it that way because, then start there, right? And I'll actually have less problems with you. Like, we might have a question about whether or not you should trust like your car, because if you don't, science doesn't work different in different fields, right? Like the methodologies and stuff that I do is the same way that we like, design planes and medical stuff and whatnot. Like it's okay. Well, we've been going about an hour, team. I still got 16 of you hanging out, but we got through that video pretty quick. I was actually surprised. I thought a 13-minute video would take longer. But let me, let's just see. Is there more answers in Genesis stuff? Maybe a short video we could go through too. I am so connected to the internet. I hope my internet's not that unstable. Shoot. Okay. Don't want your promo video, Genesis Apologetics, but do you have more science videos for us? Oh, goodness. That looks like, no, I don't want human evolution. What are their playlists? Do we have like science? Noah's flood and Pangea. Distant Starlight and the biblical timeline. That looks like what we just watched, but it says there's a second video. Hi, Harmonica Man, how are you? Oh, okay, they just have a different edited thing. That's what, okay, so we did that. Age of the Earth and the Bible. I think I've actually looked at this playlist and it's a very little like physics. Because I did the radiometric dating. And I've reviewed that one. Yeah, I've heard this one too, that like God just made it so that it would look like it was old, which like, again, if you want to believe that, that's cool. You can't prove it. You also can't disprove it because it's the like last Thursdayism. And like, I think if that's actually going to be your, I think if that's going to be your stance, then you've got some theological stuff to wrestle with. That's like, why would that, because that's like a lie, right? Why would God create the universe to be deceptive? Which I really do think that that's like non-trivial theological stuff to reckon with. It is too warm today to be a unicorn. My unicorn hoodie is too heavy for the weather we have today. Because I suppose an apology is for trying to kill us all with our golf ball sized hail. Most of you weren't here at the beginning. I want to show you the hail that fell in my yard because because. So today here in Norman, Oklahoma, it's like sunny and 75. Again, I think as an apology for trying to kill us yesterday, because I do, I live in Oklahoma, so our weather tries to kill us. Okay, so there we go. That is the hail that I picked up off my backyard, out of my backyard yesterday. It's solid, like 2 inches. You want to do some severe weather stuff? It is severe weather. We could do some like PSA. Yeah. Oh, and yes, my car survived the hail because cars were in the garage. Unfortunately, we had friends over last night, and their car was in our driveway, and their windshield got busted out. And I have spent today dealing with yeah. It's the radiometric dating of uranium to lead is how you date the oldest things in the solar system. That's absolutely right. So we do get a new roof. Found that out today. We had a roofing company out and I talked to my insurance agent, and all that jazz. So we will be getting a new roof. I know I say that very like blasé. I said this at the beginning of the stream. Here in Oklahoma, you get a new roof every 5 to 10 years. Yeah, it is. Okay. Let's talk about radar. Let's talk about a little bit of radar. Let me see if I can get a good, let me see if I can get some good radar signals from the hailstorm last night. Sorry, you can keep looking at the cool hail from my back porch while I Google things, and then I'll share my window. Radar, Norman, from yesterday. Can I get that? I think it's still up on AccuWeather. So I want, oh no, I want historical radar. Yeah, I bet. Hail is really destructive. I think the early estimates are that last night's hailstorm caused something like $1 billion in damage. Natural disasters are expensive. Let me jump to, all right, I'm gonna stop sharing that picture. I'm gonna share my share screen window. Here we go. I'm sharing, I'm on the National Weather Service homepage. Don't mind me. Here we go. So this is, okay, so here's the path of the hailstorm from last night. And I don't want to see the forecast. I want to see climate and past weather, maybe. What would be Oklahoma from yep. Archived data from yesterday. Let's see. Oh no, sorry, that's the report. What about local astronomical, climate prediction, climate resources? Shoot, I want to see the radar from yesterday, because that would be interesting. Well, okay, I'll just go off that radar signal that I've got, the image that I saved. I'll try one more thing. Sorry, I'll try one more thing. Norman, okay, radar on 28 April 2021. Ooh, there was a tornado in Pauls Valley. Okay. That's exciting. Okay. This is like the local news station. Let me pull this guy up and see if they've got some good, see what they've got. Or I'll make my face smaller so you can see me. Okay, homes, businesses, vehicles. Where are the good, let's get some good photos, huh? There we go. That's a good photo. I want the radar. I need to be faster at this, don't I? Okay. This website is not helpful. What about, all right, I'll jump back to weather.gov. Past weather. No, that's not what we want. We want radar. Okay, sorry, I'll stop sharing that because I'm not gonna be able to I'm not having trouble finding it quickly. So you guys don't need to just watch me Google things for 10 minutes. That's very boring. So I will grab the I pulled a snapshot of radar off of Twitter from weather Twitter is a delight, especially so here in Norman, Oklahoma, like 1% of the population works in weather. This is a population of 100,000 people, so there's like 1,000 meteorologists here. So, all right, so what are we looking at? Because you're looking at like different radar products here. So your top left, this guy, this is just dBz. So that is decibels. So what that is, and so that's just like decibels is like factors of 10. So what that is pretty raw in terms of that is the radar sends out a signal, it bounces off the water droplets in a storm and then comes back. And this is almost just the like that hope signal kind of, not much is done to this signal. And very roughly, the higher the dBz, the more water. So that's what you're seeing here. So this big old pink thing, that's going to be the hail core. So there's lots and lots and lots of moisture in it. And those droplets are also pretty big. So another thing that radar can tell you, if you sort of know what you're looking for, is how big the water droplets are. And for hail, that can be really important because like if you can see, oh, this is like pea-sized hail versus softball-sized hail, you know, that matters. I certainly wonder this too, my guy. Like there's lots of really, there's so much we don't know about the universe, and there's so much. Meteorology is a great example, right? Meteorology needs really smart people working on these questions so that we can better forecast events like this, right? And this event was very well forecasted. I'm not shaming the National Weather Service, but you know, there's again in like about 10 minutes last night, it was about $1 billion in damage, right? Like if we can engineer things to better withstand hail, right? That sounds like a lot. That sounds like a great place to spend your time and energy. So no, if it's just humidity, if it's still in the water vapor stage, which is what you feel with humidity, radar doesn't pick that up. Radar is going to pick up liquid water droplets. So that means it will see clouds, it will see fog, it will see rain. But it's not going to be able to see humidity. Okay. Oh, also notice, I don't know if you can see, but you see this pink guy is sort of wrapped around a little bit. You get a curve to it. That is pretty indicative of that, like you start to get that curve with really strong winds. So that's a really strong storm. So yeah, this is very much a hail core. Oh, this is fun. They've got a weather station data there. So let me zoom in and show you guys this. Up. Okay. So you see that where it is. So it's this arrow. We've got 68, 65, 10. So what this means is that the wind speed is coming from this direction, right? So that the arrow points in the direction that the wind is moving. And the number of feathers on the tail there tells you how strong the wind is. So that should be 25 knots. Each little, a full tick is 10 knots, and then there's a half tick. So that's about 25 knots coming from the northwest, moving southeast. The temperature there is 68 degrees, and it looks like dew point is 65. So that's actually an important thing to note there. Because it tells us that there shouldn't be a storm here. We shouldn't have clouds, there shouldn't be a storm here, and yet we have this high reflectivity signal. So what we know is happening here is this is for those of you that weren't here at the beginning of the broadcast, this is 3-body scatter. So this line here, that's actually a radar artifact. So there's not a storm along that line. Ooh, yeah. Okay, what radar model and forecast would you recommend for enthusiastic storm spotters? I actually really like pivotal weather. So I can pull that up for you. That's what I use. It shows a lot of forecasts. You can grab radar. So I will share that screen. Oh, so anyways, this is 3-body scatter. You get this signal because the radar signal is bouncing off of hail. And it makes it look like there's this long linear pattern that extends out of the like hail core. But it's a radar artifact that actually it's an artifact in the data. So it's not capturing what it's supposed to capture, right? But it actually tells you a lot about the hail. So let me guys show you what website I tend to go to for when I want to look at forecasts or radar or something. So share my screen, window, I'll come over here. What I use, I do like the National Weather Service. The National Weather Service is a great place to go. But let's go to pivotal weather. Here we go. So here is pivotal weather. And the first thing it shows you is all of the, this is really only for the US, but the first thing it shows you is going to be warnings and watches from the National Weather Service, which is also really useful. But let's we could go to observations or forecasts. So let's take a, so for storm spotters, I'm not sure, do you ever use the SPC Outlook? Because the SPC Outlook is really nice for Corn Tech. I don't know if you use SPC Outlook. So this is the Storm Prediction Center. It's convective outlook. So let me try to make that big. And you can zoom on different spots. I will say for convective outlook, like 1 or 2 days out is all that's going to be really reliable. So, you know, I know that we've got stuff going out on like day 5 here, but it's not strictly useful. And I'll pull up the SPC website. Oh, goodness, that's not what I wanted. I want the day 1 convective outlook. That's what I want. So convection, to get a big old thunderstorm, you need lots and lots and lots of convection. So that is very strong rising air that's going to like move moisture, heat and moisture up into the atmosphere, which is how you're going to make a cloud. It's also, you need a lot of convection or a vertical rising motion. You need that to make hail. So the way you make hail is, hail is actually really, really, really cool. So hail is cool. So you can't make hail like in December, or it's really hard to. So you really need to make it like in the spring, even though it's ice. So that seems like it would form in cold weather, but it doesn't, because what you need is hail. You need in your cloud to have a level up here that's below freezing, but a level down here that is above freezing. So you have your little water droplet, you have strong rising air, it kicks it up into that freezing space and it freezes. And then that piece of ice gets heavy and it falls down. It comes back down below freezing, so you get a little melt, it accumulates more moisture, then those strong winds kick it back up into the upper cloud bit. And it refreezes, and then it keeps doing that until the ball of hail is so heavy that the rising winds can't keep it aloft anymore. So then that's when it starts to fall. So to get hail like we got last night, you have really strong vertical motion or really strong convection. So if we're looking for this convective outlook. So yeah, tomorrow doesn't look very interesting on a convective outlook sense. So if we kind of, the colors, like green is like, hey, so these areas are probably going to get some rain tomorrow, but probably not like a severe storm. So notice, so like dark green is marginal. If you start to get to yellow, you're getting to like a slight risk for severe weather. As you get to like brighter and brighter colors, it's a higher and higher risk. So that's a great place to look if you just want to be like, hey, you know, is Oklahoma going to get a storm tomorrow or in the next couple days? Probably not, right? It's not going to tell you a lot about like, and this is more a broad regional thing. If we want to start zooming in, then let's look at our like, let me go back to the pivotal weather. So let's go to a forecast. Okay. Oh, forecast, sorry. And you can look at different things on, so National Weather Service forecast, WPC, I forget what that stands for. CPC, that's the Climate Prediction Center. So that's more like, is this summer going to be warmer than average? And then SPC, Storm Prediction Center. So let's jump over to, I'm a sucker for the National Weather Service. Let's jump over to National Weather Service forecasts. And you can change your zoom from like continental US to other places. So yes, so and the default is temperature, but we've got a lot of other stuff over here. You can do like max temps or min temps. We can also do, what's our 6-hour max wind gust forecast? So like temperature, precipitation, gusts. Yeah, so, and if you look, right, so this is Oklahoma, you know, we're not going to get a lot of wind gusts, but if we go over here to like the Texas, that's New Mexico border, right, like really strong wind gusts there. So I do kind of like to look there. If we just want to look for like radar, what is going on with radar right now, I would go to the National Weather Service homepage for your town. You can change towns here. Goodness. Sorry, I'm looking at this hail report. Anyway, but let's just pop over to radar. And I meant to click regional, but that's okay. So here is sort of, you know, the whole US radar. This is knit together from the National Weather Service's radar. So yeah, it's really only, you know, so that if we can zoom in really close, and it's right here. Oh gosh, yeah. See, there's nothing going on in Norman right now. So this is where I live. I live in Norman. But let me zoom back out a little bit so we can see things going on. So yeah, radar is always fun to look at. So if there's just, what's going on? What's going on in Boston? Looks like it's very rainy over in Albany. Nice little system. So this is a storm, right? This is somebody's getting rain, but there's probably not thunder and lightning. And I know that because sort of the highest DBZ there is only getting to the yellows, like it's pretty low. So, you know, it's probably a dreary day around the New York area, but nothing, you know, you're not going to get hail, right? You need those really bright colors in the decibels and the dBz, that really strong radar signal, in order to get that type of behavior. I make weather sound sexy. Oh my goodness, thank you. So yeah, I think that's probably, I've been going about an hour and a half and I've just like delved into random radar stuff. Somebody asked me, so radar modes and forecast products. look at just DBZ and then also look at velocities. So you can also get wind velocities out of radar signals, and that's really good for storm spotting, because you can look for circulation in the wind pattern. And I think so right now my recorded series is on climate dynamics, and I've probably got I've got a handful of videos left in that to go up, but then I'm actually going to start doing a weather 101 thing. So kind of the basics of okay, how do I read radar? What are some of these terms they're talking about? So there's going to be some new over the summer. I'm going to spend some time over the summer making some videos for the basics of weather. I'm also I just found out, I'm excited, I'm teaching a summer class for non-majors at the university in just introduction to weather. It's their weather and climate class for non-meteorology majors. So I'm going to teach that. I think I'm going to put some videos up that's kind of teaching some of the basics of that, of what I'm teaching in that class. Anti-radar paint the military uses. That's really interesting. I'm not surprised that exists. I haven't specifically heard of that before. Are you expecting hail in Texas? Let me go back. I'll pull that up and answer the question about the radar paint. So let's go take a look. Which part of Texas, if you don't mind me asking? Let me see. Now let's pop over here, and I want to go to radar. Let's go to Southwest Oklahoma. So anti-radar paint should work. Oh no, it doesn't look like you're gonna get any hail. That's thinks you're gonna, okay, in the Dallas area. Oh yeah, y'all got hit hard yesterday, didn't you? Okay, I want to come down. Here's Dallas. So it looks like, so one for right now, this is your only little system coming through. That's a really weak system, and it might even pass north of y'all because it's probably going that way. By the way, all those little dots, that's actually, if it's about sunset, those are probably bats. That's probably not water, that's probably bats. So yeah, I don't think you need to worry in Dallas tonight. So for the paint, what that would do is it would, so the idea is you would want to scatter the radar signal kind of in all directions, so that it bounces in all directions instead of it hits the object like the plane and straight back to the radar dish. So that would be a very cool, that's almost like an optics problem. That would be pretty cool, but I'm assuming that's how that works. Yeah. Okay, team, I think I'm gonna wrap it up here. I had so much fun hanging out with you tonight. I hope you liked our random dive into hail and radar. That's always fun. And it was a good palate cleanser for me after the really bad gravity physics from Genesis Apologetics. What do I have to shill? There will be a normal scripted video out on Sunday. It is on the hottest period in Earth's climate history. And so we're going to talk about that. And then next week, I'll do a live stream probably on Wednesday. Somebody emailed me a video that looks really interesting. It's young Earth creationism stuff, but it's talking about some of the stuff that came up in my debate with Kent Hovind when he's talking about hydroplates and how you get craters on the moon by exploding things up from the Earth. And that's going to be a blast to look at. And then another thing to look forward to in the next few weeks, me and Dapper Dino, Gutsit Gibbon, Cheshire, TD Lane. Oh, so we're gonna start doing a Dungeons and Dragons stream, and I'm gonna DM it. So I'm excited about that too. Yeah, so if you want to see me in some of my non-science content, that won't be on my channel. That'll be on Cheshire's channel. But I'm excited for it. Okay, you guys have a lovely night. Stay safe, and I'll see you soon. Okay, bye. Oh, you can't see my hand waving. Bye, team.